anybody got any questions? I noticed on Slack, Kerry, you had some questions that you would like to ask. Go ahead.
Sure. I'm wondering about DVFS, if dynamic CPU frequency scaling really up, or you say
Hello.
how do you handle frequency scaling?
I think Kerry bandwidth is a bit limited. Looks like it has connection. He has connection issue now.
Yeah, I think it's.
Go ahead.
I did.
How do you handle dynamic frequency scaling?
I didn't completely get the question because
I think he said.
but
Sorry. How do you handle dynamic frequency scaling?
okay. So right now in our simulation, we disable the VFS. I mean, we use the governor for the user space for the CPU frag. This governor, what it does, it's set to the specific frequency. This is because we want to apply the matching for the scaling frequency. Even though if we go with the power save or the other governors like on demand, we haven't seen that much differences in our cases. This is probably because our test cases are not very heavy, but for the better accuracy, we disable in our VCAS, so we let the application to run on the same frequency. The major concern that we have was not related to this on demand because the VFS just in our cases we saw that changes the frequency a little bit, but the main problem was in the big little architecture that we experienced on the mobiles, which at some point they shift the calculation to the little cores, which has so much different frequency. Different gaps in the frequency. That's why we disable all big little architecture, and we set that all the cores goes with the specific frequency. Yeah, this is the case. This is in our prototype, but we could model that, for example, for big little architecture, we could also change that some of the core changes the frequency to the little architecture, for example, for the
Thanks, that makes sense. What about multiple applications running at the same time?
Multiple application. In VCAS, we only consider that the application runs in an isolated way, so there is no contention. But if this is the case, in the scaling factor matching in the VCAS, we have to consider this fact. For example, how much the application want to consume each of the resources. For example, if it's gonna use the network, for example, you have to set a limit. For example, it used 200 megabits of the network bandwidth. So in that case, the scaling factor that we match would be changed. But right now we consider only isolated benchmarks. Yeah, thank you.
Okay, great. Robert, you had a question?
Yes, hello. I was wondering if you could speak towards the difficulty of calculating the scaling factors in practice.
Yeah, calculate. This is the most difficult job of the VCAS. That's why it requires. So we consider two cases. One is the user gives you this information about the system. So if this information available on this for the system, for example, the peak performance of your memory or the CPU the frequency that CPU runs on that's okay. We're going to use that information. Otherwise, we have the series of performance experiments for each of the components. We set a couple of, for example, for the CPU scaling factor, we have a benchmark of like 5-6 CPU benchmark with different workload, but they have the CPU intensive benchmark. So we run that and we compare the result in that case. And then this result gives you the scaling factor, which might not be completely accurate, but because we disable all the DBFS, we saw that it gives us a good result within like 16% threshold, which is kind of acceptable for, because considering that the application runs at the performance of the hardware. So this is much better than the, for example, circuit accurate emulators that takes hours just for one performance run.
Okay, thank you.
Thank you.
Great. And Daniela, did you have a question? You're on mute, Daniela.
I was saying, oh, sorry. Yeah, because I was unmuted while recording. So, okay, my mistake. No, I was saying very nice and interesting work. My question is, are you also considering system where part of the computation is on GPU? Because, for example, with machine learning stuff, you have a large speed up with the GPUs, and I think this would be a very relevant direction for your work.
Yeah, that is actually a good question. And this is actually in many cases, in many applications. But right now, no, we don't consider the GPU or any accelerators. So we are considering only the performance analysis on the another CPU. So we, another system that only use the CPU and memory and I/O. And this I/O right now considered only to the network. But if you have or other peripherals, so it is be extended in a way that in the scaling factor matching, we have to consider this I/O, for example, run series of the experiments to match the components between two, and at that level you could threshold for example, the writing speed, the I/O speed, and this stuff to apply the cases. But another situation specifically for the for the GPU is that we run this we develop this cost profiler for the GPU because they have their own threads, so we could apply the same thing. But the problem we were first look into that to develop cost for the GPU, but the problem is that you cannot easily insert delays. You cannot easily change the frequency of the threads on the GPU, so it's going to be problematic. So right now, we only consider the system that doesn't use the GPU or any accelerator at this point.
Okay, thank you.
Great, thank you. So if there are no more questions, then we can move on to the next